In today's video, we're going to be really doing a quick late night episode here today. We're going to be going over both the European model and the GFS model as requested by a lot of you in yesterday's video. It was kind of noted that I only showed the European. I did it to kind of go quicker. Both models were showing a very similar output, so I didn't feel like really comparing it. A lot of you commented about it today, so we're going back to the drawing board in this one and just going over both of those models with you guys. So let's dive into things. First off, it's the European model, and I want to get to where the storm's really approaching here. We start out with plenty of freezing rain here in the southern regions of North Carolina, Tennessee, and Virginia as well. I'm kind of wondering if that is going to accumulate as freezing rain. I would definitely advise you to prepare for that to be a possibility. But ground temperatures are trending towards being a little bit above freezing, which could make it pretty difficult for that to occur. Not to say that that's impossible. Everything is still just modeled guidance, so there's always a good chance that, ground temperatures end up being colder than projected. But that is in question right now. So we're, of course, going to prepare for the worst, hope for the best. I think that is the best advice in this type of a scenario. Certainly prepare for the worst case scenario, as this is a very major and very impactful storm. We can see that the freezing rain kind of trends northward over time. It actually extends into this kind of mountainous area of Virginia, as that low is located right over southeast Virginia there, pretty close to the Delmarva. We get heavy snowfall along this kind of West Virginia border, which is extremely mountainous, and that extends all the way into Maryland and even southern Pennsylvania there. This is by the time we're reaching about 8 p.m. on Saturday evening here. And by the time we're reaching about, I would call this maybe 6 or 8 a.m. on Sunday, January 7th, we can see this extremely heavy band of snowfall setting up for northeastern Pennsylvania, northern New Jersey, a lot of New York here into Massachusetts, Connecticut, Rhode Island, and then Vermont and New Hampshire here. So definitely a very, very heavy band of snowfall, especially as this low is a 993 and decreasing in pressure, which means increasing in intensity, of course. So the storm is rapidly intensifying, and that is causing these heavier bands of snowfall to actually become more and more intense over time. Now, it's still in question if we're going to see mixing issues around this coastline of southern New England into Long Island and nearby New York City. I'm leaning towards that happening. I'm leaning towards that being the case, especially for this coastline. As this is going to be relatively close to the low pressure system, I think that there's going to be warm layers of air above the ground but below the storm. So at somewhere where that precipitation is falling, and of course this leads to sleet and sometimes rain, I think that's going to be an issue near the coast because of the proximity there of that low pressure system. So keep that in mind. Of course, just like we said for the southern areas of the Appalachian Mountains, prepare for the worst, prepare for an all snow event with extremely heavy snowfall and large snowfall totals, but hope for the best. Hope that we do see some mixing and it's a less impactful system. Of course, if you're hoping for snowfall, perhaps you don't have to drive in it. Perhaps you're a younger person watching this and you're going to be at home. Definitely, you would probably want to see an all snow event in that case. So definitely there's a variety of things that people want, and I'm trying to kind of dish out information, trying to relate to you guys' perspectives, but there's a wide variety of them going on in my comment section usually, so it's definitely hard to do all the time. We see everything pretty much clears up by the time we're reaching right around Monday afternoon or Monday morning. Things will be definitely cleared up by then. Might have a few flurries left over, but should be all said and done. Let's go ahead and compare here. We're going to go over the GFS model and see where there's similarities and where there's differences. We get this heavier band of freezing rain set up in between Virginia, North Carolina, and Tennessee once again. I want to keep going. That's by Saturday morning. And by the time we reach about Saturday afternoon, evening time, we have this 1004 over southeast Virginia. And then we have the freezing rain extending up into Virginia and portions of West Virginia, with that heavy snowfall here for portions of West Virginia, Maryland, and Pennsylvania. Looking pretty similar so far. As we continue things on, we get a very similar path with this low pressure system, and this is the brand new 0Z GFS, and we're getting the benefit of seeing this because of how late this video is coming out. But this one actually came a lot closer to what the European model is showing. The 18Z run, I'll actually show you it real quickly just so you can see the difference here. So it's going to be the same exact hour, but a different model run. And we can see it's a lot further to the southwest. So this has trended a little bit north there over the past 6 hours on this newest model run. So definitely seeing a northern trend on that GFS looks a lot closer to the European model now, which is what you want to see when we're in this range. You want to see these models trying to come together, and certainly this was a big step in that direction. Definitely could trend south again, but these things tend to fluctuate, and it's going to make all the difference where this low pressure system ends up actually being. So keep that in mind. But again, very similar to the European model, heaviest bands being in here for northeastern Pennsylvania, northern New Jersey, southern New York, Massachusetts, Connecticut, Rhode Island, southern New Hampshire, and southern Vermont. I think that's going to be your bullseye zone for this storm. Keep in mind that we do have some mixing issues, again, like I mentioned, probably presenting themselves for the coastlines here of southern New England into Long Island and portions of northern New Jersey. I would not be surprised if that's happening, again, especially closer to the coast. Could be in the form of sleet, could be in the form of rain, could be a wintry mix, but I think that some mixing is going to happen there at some points during this storm. Probably as it slips to the east here, because again, the proximity to that low pressure system is everything here. As it slips off to the east, don't be surprised if you switch back over to all snow, even for the coastline here on the back end of this system. I think that, you probably start out as all snow. As that low climbs the coast here, I'm going to just walk you through what I'm talking about. So as this low is further south here, obviously, this area that I'm circling in is not close to the low as of now, so you're probably starting out as all snow around here. Definitely a chance. And then as we get later into the night, you maybe even all snow as that heavy band moves in. But likely, as this low pressure system draws closer and closer, you do run that risk of having a couple hours of mixing in there. Right about there is when it's at its closest. I know that this model is showing blue, but I'm just telling you my opinion from my experience with these things. I think mixing could present itself as an issue. Again, eastern New Jersey, Long Island here, southern Connecticut, southern Rhode Island, and southern Massachusetts, especially as that's going to be very close to this low pressure system. And then as it slips off that east coast, what we see is there's a cold front underneath here, and this is allowing for colder air to move in, should switch back to all snow on the tail end. So if it's minimal, I think it won't hinder accumulation too much. It's mostly just going to be the missed out accumulation during that mixed period. And if it's more prolonged, it could start to eat up some of that accumulation that's already taken place, which of course could impact the end total snowfall. There's a lot of variables there, but I just think that to some extent mixing will present itself as an issue for these areas. Keep that in mind. That all comes to an end. Let's take a look at the total snowfall. This is the European model, and this is the Kuchera ratio here, which usually takes into account some ratios as far as the temperatures and everything, which does impact how much snowfall accumulates. And we can see very heavy snowfall totals here, even close to the coast that I was just mentioning. So you're probably wondering, why in the world is it showing that if he just said it's going to likely not stay all snow the entire time? It's once we take a look at this here, which is going to be your accumulated positive snow depth change, which is a little bit more of a dynamic tool here. Tries to take into account mixing, tries to take into account ground temperature, tries to take into account anything that could hinder accumulation, and tries to just count the total accumulation due to this storm. Now, this is the total model run. I want to get us back to just that single storm. And here it is. And we can see that heaviest band sets up somewhere in here. I even think this is a little too far south from what I'm thinking. I think we see it a little bit further north than this over time. That's just my gut feeling here. Definitely could be south like this too. So keep that in mind. But when we really zoom into it, and I might even need to take on a even more zoomed in look here. So let's go to, I don't know if we're going to get it. We might have to go to a state here. So let's do this. We usually don't zoom in this far, but we're going to go ahead and do it this time because I think this calls for it. Let's see. This is even better. Here we go. So we can see that, these areas in the purple here are seeing 6 to 10 inches of snowfall, and that line rides just to the north there of the coastline, as you can see. Even on this eastern coast of Massachusetts, it stays kind of away from that coastline and does something like this, and that's your bullseye according to this model run. So clearly this warm air kind of entering onto the coast here is causing lesser snowfall totals, likely in the form of mixing, likely in the form of just some warmer air overall. There's a couple of factors there, but mixing will likely present itself as an issue in my opinion. And even if we see a very far southern solution like this, I think that we're likely going to see the bullseye a little bit inland. Like this is probably like 10 or 15 miles inland. maybe even less. And I think that that's a much more realistic outer kind of radius for that bullseye area. We can see some higher totals in here, like 10 to 12 inches in a couple of spots here. I think that that's going to be your spotty maxes that you're going to see out of this storm. Something like 15 inches can't be ruled out either. That's how I kind of see things as of now. So keep that in mind. I definitely think that the mixing will present itself as an issue. And also take note, I want to go back to the northeast view here. That we have lesser totals to the south. Even though they see pretty heavy snowfall, we also get rainfall at times. We also get freezing rain according to these models. And we get a little bit less down here, more like a bullseye of 2 to 6 inches. It's really only as you move into Pennsylvania, northern New Jersey, and then into New England, where we're looking at these 6 to 10, maybe 6 to 15 inches total out of this storm. Now, as we take a look at the GFS, again, this is that Kuchera ratio. And we're getting these like huge totals, maybe even seeing a little bit less along the coast here on this. But it's when we take a look at this positive snowfall depth change. I want to see if this fixes that issue. So first off, the GFS has pretty bad resolution to begin with, but we're getting these kind of like white boxes near the coast where it's not able to even give us that information. So, you know, I wish that we had a more accurate representation of this. Clearly we don't right now. At the 10 to 1 ratio, you know, we're getting a lot more near the coast. This Kuchera ratio does try to lessen the amounts down here, so it is picking up on some of those warmer temperatures already. Probably can't consider the rainfall that's happening in the ground temperatures like your positive snowfall depth can. But this definitely gives it a better effort than just the 10 to 1 does. So where it's colder, we actually get more snowfall than the 10 to 1. Where it's warmer, we actually get a little bit less. So this ends up actually being usually a little bit more realistic and more accurate. It really just depends on the situation, and you have to kind of use discernment to figure out if that's the case or not. But definitely this bullseye is somewhere in this area as well, kind of northeastern Pennsylvania, northern New Jersey, southern New York, northern Connecticut, northern Rhode Island, and then Massachusetts as well, southern New Hampshire here. So that seems to be the bullseye spot here on both this model, and also, as you can see, the European model is not too far off. Definitely similar. I would say the GFS after the newest 0Z run is a little bit further north perhaps than the European model, but pretty darn close to showing a similar output here. Which at the range that we're at currently, you know, about 2 days out from the start of this system, maybe even a little bit less at this point, this is the type of agreement we want to be seeing at this point. So definitely heading in a right direction from these models, probably getting a more accurate output here. Definitely a lot of good news, and probably means we're a lot closer to getting an accurate output from these models. The problem is, and we're going to talk about this in tomorrow's video, is we need to switch over to the short range models. We're going to start using models like the RGEM, the NAM, models of that nature, because we're moving so close that we need to focus more in on those micro details. So that's starting tomorrow. We're going to have a lot more content coming up, and it likely won't be as late as this one, thankfully. So anyway, thank you so much for watching. I'll see you guys in the next video. Be sure to subscribe, hit that bell icon for daily notifications, like the video, and leave a comment down below. I'll see you guys in the next one.